The broadcast is now starting. All attendees are in listen-only mode.
Well, good afternoon, everybody, and welcome along to DBA Fundamentals Down Under for the month of August. Once again, my name's Warwick Rudd, and I'll be hosting this month's session. In this month's session, we've got Anthony Nocentino talking to us about containers. Now, I do want to remind you all that this session is being recorded and will be available on the DBA Fundamentals archive site in a few days' time. If you do have any questions throughout this session, please do not hesitate to ask. I will be monitoring those questions and putting those through to Anthony. Now, I do have a little bit of housekeeping to run through before I hand over to Anthony for this month's session. First off, a big thank you to our sponsor, SentryOne. Without our sponsors, it does make it difficult for us to continue to put on these sessions for you. If you haven't already been to SentryOne, make sure you go there and have a look at their fantastic set of downloads, articles, videos, demos, etc. for you, the data professional, to assist you in your data professional career. With that, make sure that you stay connected with past, register for any other virtual chapters, just like this one, where that you're able to expand your horizons around all things data professional. So with that, I'd like to hand over to Anthony for this month's session.
Well, thank you so much, Warwick. I appreciate it, and I appreciate everyone coming. So let's go ahead and get started. Are we looking at a PowerPoint deck? Looks like we are.
We are.
Cool. All right, so let's get cooking. This is Containers, You Better Get On Board. I am Anthony Nocentino. I'm a consultant and trainer and founder of Nocentino Systems, where I specialize in system architecture and performance. Data platform MVP for the last couple of years, and a friend of Redgate. That's my contact info at the bottom. It's just email address, Twitter handle. If you don't follow me on Twitter, please do so, because that's kind of my main way to interact with the community. I blog relatively frequently, and I'm also a Pluralsight author. And I'll touch on some of that a little bit later. In the end of the session, maybe I'll have some free trial cards to give out if anyone's interested in those, to get access to some of my content there. So we're going to cover a lot in this session. Basically, if you've never seen a container before, this is the session for you. We're going to introduce what containers are, how they work, what they look like on the inside, and have some fun with that. We're going to look at why you would do this. Like, why would you want to put applications in containers and use those in your data centers, and how we do that. Then we're going to look specifically at why you'd want to run SQL Server in containers, and we can leverage some of the techniques and technologies that the containers provide to help provide some interesting capabilities to SQL Server when we deploy it with containers. After that, we'll check out the container universe. Since this is an intro session, we're going to look at who the big players are in the container industry, look at some of the other different container runtimes that are available, just to kind of get a lay of the land there. And then lots and lots and lots of demos. About half of the session is demos, where we'll see how we can instantiate SQL Server just in a matter of seconds, which I think is fantastic. We'll look at how we can do this for real and production systems with container orchestration, and we'll also look at high availability container scenarios, how we can leverage the technologies that containers provide to give us good HA out of our SQL Server platform. And so let's start off with introducing containers. We're kind of familiar with the concept of machine virtualization by now, with virtualizing or multiplexing on CPU, disk, and RAM, right? What a container does is virtualizes the system, their operating system itself, right? Where we're going to share the kernel and its functionality and the resources that the kernel provides, right? So in terms of things like CPU, disk, and RAM, if I need to allocate a process, allocate some memory, perform some I/O, right? So the abstraction happens at the kernel level inside of the OS rather than at the machine level when we're talking about VMs or machine virtualization. We look at containers and we figure like, well, what is a container really? A container really is kind of the binaries, libraries, and the file system components that make up our application, right? So here you're going to see this graphic throughout the remainder of the session. It's this arbitrary application called app1. It's going to, the container itself, that shippable unit that we're going to move around is going to be the binaries of that application, and the libraries, DLLs, and maybe file system components that that application needs to run, right? That's the unit of allocation. So when we talk about containers and from a design standpoint, you generally speaking have one application inside of a container, right? It's a very narrow scope of deployment. And we'll look and we see at SQL Server later on, we're going to see there's literally going to be just SQL Server executing inside the container. Because this winds up being the unit of work. Because in the end, when you start up a container, all a container really is a running process with some isolation boundaries around it, such that it thinks it's the only thing running on top of that operating system. When we launch SQL Server, you're going to see it thinks it's the only process that's running on the platform, which is pretty cool and provides some interesting capabilities, which we'll talk about later. Now, one of the key things about containers that's really spooky to data professionals is that containers are ephemeral, which means when I delete a container, that thing's gone for good, which is the exact opposite of what we do as DBAs, right? Our job is to make sure that things stay around for as long as possible, right, in terms of our data. And what's interesting about containers is we're going to decouple the configuration and the state from the platform, right? We're going to have this thing that is the container. We're going to assert some configuration on that externally, and we're going to store our data externally from the container, which means that container is just kind of a cog in the machine that we can pick up and throw away, right? When we need to bring another one back, we can bring it back, assert the configuration on it, point it to where our data is, our state, instantiate that container, and we're right back where we left off. And you're going to see how that works in a little bit when we get into the demonstrations. And so let's start off with a comparison. Now, I'm going to beat up on virtual machines for a little bit here, but know that I love and respect virtual machines, been working with them for a very, very long time. But let's look at what we've done with VMs over the years. So we bought some hardware, we put a hypervisor on it, then we installed some guest operating systems on top of that. And on top of that, we installed some applications. We built this thing, and it became kind of the core of our data center, right? These guest OSs and all these apps became the things that we had to love, care for, and feed inside of our data centers. And I ask you this, doing this, does this make anything better for us, right? I don't know. It made it a little bit better because we got better utilization of the hardware, but hardware's pretty cheap. We still got stuck with dealing with maintaining all of these guest operating systems and making sure that all these applications were up and running at all time. And our configuration and our systems are very tightly coupled together, right? We had to worry about things like, well, is PRD SQL 001 up all the time? Is, apps 02 up all the time? And that became a very tightly coupled relationship between the applications, the guest OS, and all of that stuff together in our data center. Now, in addition to that, let's kind of discuss what's so hard about virtual machines. Well, first off is we have OS resource overhead. Now, I know there's things like page sharing and compression and all these cool technologies and techniques that happen at the hypervisor level, but we still burn a lot of CPU time inside of our data centers just running the OS, right? And running multiple OSs on all of that hardware in those large density virtual machine environments. Patching is really hard, and patching takes a lot of time and a lot of CPU, and none of that provides any value to the business, right? I have OS resource overhead, I have patching that takes all this time and burns a bunch of CPU and space because people forget to delete patches and things like that off the service once they're done, but that gets to be a little bit challenging to manage. Troubleshooting, right? If something goes wrong with the VM, we have to have some sort of advanced technology technique or put our capes on and figure out and troubleshoot that problem to bring that system back. What's another thing that's hard? Upgrades. I like to think that one of the hardest things to do in IT is upgrading an operating system. Full stop. Because when you have to upgrade the OS, you have to touch everything that is on that OS, the applications, the databases, whatever it is that you've changed out. And that can be very challenging and very hard to do over time, right? Going from 2003 to 2008 R2 to 2012, those were hard transitions, right? Let alone what we had to do at the database tier. And deployments. What's the fastest you could roll out a virtual machine in your environment? Minutes? Tens of minutes? Hour? How long does that take to get it done? You're going to see in a little bit that we can roll out a container in seconds, which will blow you away in how quickly you can deploy an application. And really, that comes down to this. Does any of this stuff on the screen move your business forward? Does it get code out to production faster? Does it get additional functionality that your applications need so that you can close more deals from a business standpoint? Does any of this help move your business forward? Not really. And so let's kind of shift gears and focus on containers and how they can differentiate themselves from VMs. Well, containers can be containers can be deployed on a physical or virtual machine. In this diagram here, I have physical, but it can be both. And we could just install a regular old host operating system. Now, if that host operating system has the capabilities of providing container isolation, we'll learn about the internals of that a little bit, then we can leverage that to deploy containers on. Both Windows and Linux have this functionality. And then what we do is we take that container, which contains our application, and we start that process or start that container on the host OS, and it thinks it's the only one on top of that operating system. So I can come along and install additional, I can come along and instantiate additional containers, application 2, application 3, and they all think they're running independently of each other on top of this host operating system. And that thing, that container, is the unit of deployment. So as long as I have this basic OS underneath that, I can start this container and instantiate that application on it. Now, application 1 doesn't see app 2 or app 3 when it's executing. It just sees itself and the things that it needs to execute at runtime. So it's binaries and libraries. And if there's a conflict between a library in application 1 and a library in application 2, well, that's no big deal because of that process isolation. They can be completely conflicting libraries and be perfectly compatible because they're executing inside of the container with that process isolation that occurs at the kernel level inside of the host OS. Now, if app 1 needs to talk to app 2, it can simply do that over the network, over TCP/IP, or whatever protocol it needs to communicate. And I like to think that this is lower maintenance because the surface area of stuff that we have to maintain is reduced, right? I don't have to deal with that whole that whole guest OS tier now. I have to deal with the host OS, that's still true. But I like to think that this is going to be a lower maintenance deployment because I've been challenged on this when I've presented on this. Well, people think that this isn't quite that much lower maintenance, but I like to think it is because you're really kind of commoditizing the things that participate in this environment. We don't get very tightly tied to this server has to be up at all times with PRD SQL 001 pointing at apps 02. And we'll learn about those abstractions a little bit later when we talk about services. Now, why are we doing all of this? Because it's all about going fast. It's all about being able to take that container, that app 1 container, and get the code from the developer's workstation into production as absolutely fast as possible because we want to be able to get code and business functionality into production as fast as we can so that we can beat our competitors, right? That's what it comes down to when we're talking about why do we want to do this and why do we want to leverage containers? Because you're going to see when we deploy a container, something as monolithic as SQL Server, as massive as it is about 1.3 gigs when I need to deploy it as a container, excluding the data. But that's pretty darn small. And in fact, that's really trivial to move around in a modern data center. And so that's the number one thing that containers bring to us is speed, right? I can move a container around. I can get the code out from a developer's workstation. I can get it into production very, very, very quickly. The next thing is patching. I don't really have to be so concerned about patching my applications and making sure they're up and all those kind of things. We kind of build this very linear process where I'll take what I need from my container registry, patch that application, and roll it out very, very quickly, leveraging the same techniques that we're going to describe in a little bit. Troubleshooting gets to be interesting in containers as well because, well, if something goes wrong with my container, and I know if I just delete that container and replace it, I'm going to go back to the starting state of the container due to the ephemerality concepts that we introduced earlier, well, then why do I need to troubleshoot it? Why don't I just kill it and redeploy it so that we can get back to a known good state? We're going to see how that works in a little bit when we get into demonstrations. Upgrades to get to be a little bit easier. Since we're decoupling state and configuration, I could just bring along a new version of the container and pop it in, point it to configuration, point it at the state that it needs, and start that application back up and running and affect the change that is needed in the upgrade. And this all really culminates in this, right? Is we're going to get fast and we're going to get consistent deployments because we're all going to do these things in code. And we're going to write code that models our systems and gets those to be instantiated and running in our data centers. Now, it comes down to this though, and it's kind of a point that I'll beat home a little bit today is nobody cares about servers. They care about services. Can they get to the data? Can they get to the service that they want to consume, right? Nobody cares if PRD SQL 001 is online. They care is the application available? Is the service ready? And so keep in mind that abstraction as we go through the next upcoming slides and as we talk about container orchestration at the end of the session. And so it comes back to this picture here again. If we need to make a change to the environment, we don't care about PRD SQL 001 anymore, or even app 1. I'm just going to kill that application and roll out a new container, right? And either affect that change if I take a patch or a new version of my app, or if I was troubleshooting, well, all right, that's cool. Kill the container, redeploy it, get me back to a known state, good state to get my application up and running faster. So kind of a recap and kind of bring together all those points is like talk about why we would do this. Like, well, why do we need to containerize apps and how do we leverage that in our data center? And I talked about this already. The number one reason is reducing, well, not really reducing development time, but reducing time to get code to production. Get it out of the developers' workstations and into production systems so that people can consume those applications and those changes more quickly. And we can do that with deployment automation. You've heard these terms like pipelines and things like DevOps scenarios and CI/CD, or continuous integration and continuous deployment. We're going to write code that makes those changes for us, and it's going to be fast. We're going to roll out changes in code, and it's going to automatically roll through our pipeline, our build pipeline, into our deploy pipelines, and roll out into our production systems. Now, to do these things, we're going to need a concept called orchestration, which we'll talk about a little bit later, but we're not going to get into the business of instantiating containers by hand. We're going to leverage a thing called a container orchestrator to do that for us, and we'll talk about those concepts a little bit later. Again, if we need to do this for real, we're going to need high availability, and we can get that from the platform where we look at things like container orchestrators and how it can respond very quickly to things that go wrong. And again, kind of culminating on this point, rethink how we deploy our applications. It's the service, not the server. And again, we're going to cover that in pretty good detail when we get into the orchestration section. Now, shifting gears over to the container universe, this is the Docker whale, who I believe his name is Moby. It's kind of the cutest marketing icon in all of IT at the moment, I believe. Although if you are working with Docker and you're on Windows, you'll see the Docker whale in your system tray, and if something goes wrong, he gets a little Band-Aid on his cheek there because something bad happened, but I think it's adorable. But let's talk about what Docker is. Docker is a technology, right? Docker is a toolkit to start containers and aggregate the resources that are needed from the underlying OS and present a running container on your system, right? That's a technology. It's available on Linux, Mac, and Windows. Docker Inc. is a company. Docker Inc. provides software and additional software, enterprise software, to support Docker containers. Now, they're tightly coupled. They're founded by each other, but the Docker technology is actually open source now. It's been given to the community by Docker Inc. There are other container engines too. Docker is kind of the big fish, pun intended, when we're talking about containers and container runtimes, but there are others available. Rocket, CoreOS, Windows has a container runtime in 2016. And if you come from kind of the older Linux BSD days, there was a concept called a Cheru jail in the late 90s, early 2000s, very similar in concept, just a little bit different in implementation. So conceptually, very similar to how containers assert process isolation. We'll talk about those internals here in a few minutes. Now, getting containers. So we've kind of gone through the why, right? Kind of gone through the benefits, kind of gone through what these would look like in our data center. Let's talk about how we're going to start using these things and what it looks like when we want to consume those. So when we talk about containers, there's these things called images, right? And images are going to be the code, the runtimes, the binaries, the libraries, and the environment variables that make up our application, right? That's that app1 box that I showed earlier and we've used throughout this scenario. That's the thing, right? Images live in registry. So if I'm a developer, I'm going to take my image, I'm going to build it, I'm going to store it in a registry. And so kind of the main one out there is Docker Hub, where you're going to find most of the container images that you're going to consume. Now, Microsoft has their own container registry at mcr.microsoft.com, which I'm going to make the assumption is that it's an Azure container registry. An Azure container registry is an Azure service where you can build your own container registry to store your own containers, which I use for my own testing and in other scenarios. You could also build your own internal container registry too on-prem if needed. Docker files define the Docker image. It's basically going to be the description of what the container looks like. What program do I start when, or what executable do I need to start when the container is started up? Do I need to expose a port? Do I need to mount the volume? That's going to be all listed inside of the Docker file. And now let's kind of walk through the pipeline that it takes to build and run a container. So if I'm a developer and I want to create an image, I'm going to write a Docker file and I'm going to copy my application into this container image, and also any required binaries and libraries. I'm going to do what's called a Docker build, and the build's going to read the Docker file and then copy all of the components and make this binary image that is then pushed to a registry and stored there, right? And so when someone wants to come along and use my container, they're going to pull that container, and it's going to be run on a physical machine or a virtual machine in the container runtime, and it's going to instantiate that application and provide the application to whoever needs to consume it. Now, if we look at the registry to the left, if you're building your own containers, that's going to be where you are. But generally speaking, we're going to be consuming containers that someone else built. For example, today we're going to be consuming SQL Server containers. Well, Microsoft is doing the build push part, and we're going to be doing the pull part. We're going to pull the container down and run that on our system. But if you're writing your own apps, you're going to do the whole pipeline. If you're consuming on someone else's containers, it's going to be the scenario that I just described. So let's go ahead and look inside of the container a little bit to get a feel for what's really going on and how these things kind of provide that isolation that I described. So we have this concept of a shared OS, right, where we're kind of talking about they're going to have OS virtualization of resources. And so one of the key things that has to happen when we're doing that is to provide resource isolation, right? And so what containers do is they provide these things called namespaces, which I like to think of as like analogous to like a swim lane for a process to kind of live in, even though everyone's still kind of sharing the same underlying resources. The namespaces that are provided are for kind of the core functionality of what an operating system provides, right? Operating system provides processes, file systems, networking components, inter-process communication, and kernel isolation. But what namespaces do is put boundaries around a process for any time a process needs to access the operating system. So if I start up a process and I need to read and write a file, well, that's going to be completely independent of another container running on my system, but we won't see each other at all. Now, in addition to resource isolation, the container runtime also provides a resource governing with a concept called C groups. So analogous to resource governor, but at the OS level, such that I can provide limits on memory consumption, CPU shares, disk IO, network IO, and things like that. In addition to the isolation and resource governing, we also have this concept called a union file system. I described how a container, when it's executed, or a container is ephemeral, right? Well, the image itself is read-only. And so when I instantiate a container, it's going to, when it needs to write, it's going to write to what's called a writable layer. And it's the job of the union file system to take what's part of the container and in the writable layer and bring that together and present it to the running application as a single usable file system. And so that's how the application thinks it has access to writable OS, but in fact that the container image itself is read-only, but it's writing using a copy on write technique to the writable layer. So let's move into that concept in a little more detail, right? Because we're data pros, and it's our job to keep data around as long as possible. And well, containers are ephemeral, right? Well, what about my data? Well, let's get into that a little bit more. So back looking at our application architecture here, we described the writable layer a second ago, right? If I'm changing data inside of the container, it's not going to be changing the image, right? That image is still like this read-only thing that's going to be on the host OS. I'm going to copy and write data into the writable layer, and the union file system presents that back to me as a consumable thing, or back to my process. If I delete that container, that writable layer goes away. That's where people got to get tripped up when they think about the persistency of containers. If I start my container and leave it up and running, and I don't delete that container, I can stop it, but as long as I don't delete it, that writable layer is still going to be available to me. If I delete the container, then that writable layer is gone. And so you're thinking, well, Anthony told me about all this cool stuff where I can just kill the container and redeploy it and all that fun stuff. Yes, you can. And let's talk about how to do that. So Docker data volumes provide a Docker managed resource that's independent of a container. What do I mean by that? Well, what's going to happen is Docker is going to provide some file level resource from the underlying OS and present that into the container at a particular file location or directory location inside of the container. So the application that's running in the container thinks it's reading and writing from the locations that it wants to, but in fact, Docker positioned a volume at a specific file system location that is now actually external to the container. It thinks it's writing to where it wants to, but the container runtime is making sure that that stuff is stored external into the container, which means we can throw away our container, start up a new one, mount that volume in that same location, and get state back over time. And we'll see that in some demonstrations. Now, Docker storage is a very complex topic, and I strongly encourage you to dig into it here. I've done it not enough justice by covering it in one slide, but go ahead and check that out to get into some more detail. So let's talk about running SQL Server in containers and why would we do that? Well, all the same reasons that we talked about so far. We can roll stuff out fast. You're going to see today how we can instantiate containers and many containers very, very quickly. I don't cover it today, but you can very quickly switch containers out and upgrade versions. In fact, if we want to kind of skew from the game plan, maybe we'll do some upgrades from 2017 to 2019 if we have time. But we have that ability to just do this in single lines of code to go from between versions of SQL Server. It becomes a really, really, really captivating and interesting technique to how to manage our data platform. And I challenge you with this, and it's kind of some thoughts for the evening, is if we change, or wherever part of the day it is, wherever you are in the world, for me it's the evening. But what if the unit of persistency for your system is not the server, but it's a database, right? That's the thing we need to be around. And this container just comes along, we put a container there, and we just make sure that the data is behind it. And then we point our users at the application and they're good, right? If the container goes away, I'll just put another container there. And we get away from taking care of that guest OS. And it becomes a very liberating thing in how we manage our data platform or our applications in general. Now, containers to SQL Server are available for both Windows and Linux. If you're going to use containers in production, it's got to be Linux. There's no production support for Windows containers now. Today, in this session, we're going to predominantly talk about, or entirely talk about, Linux containers. But if you want to get into Windows containers, check out that link there. And again, I talked about non-production use, production on Linux. Right now, there's no Windows authentication inside of Linux containers, but that's okay. Maybe we can use SQL authentication, but I do know from the product team that it's been said publicly that AD support is in the pipeline. So hopefully soon we get that to play with. Now, let's go ahead and do lots and lots and lots of demos. So I think most of the rest of the session will be demos. We're going to pull an image. We're going to run a container. We're going to access that application that's running in the container. We're going to connect into the container, kind of poke around a little bit. Works even a special request to show how we connect Azure Data Studio into our container. We'll do that as well. And we'll look at data persistency. You can see how that all comes together. So let's go ahead and shift gears. Are there any pressing questions on the queue, Warwick?
So we've got one question here at the moment. So as I understand, SQL Server Configuration Manager couldn't be opened in the container. How could we configure things like protocols, named pipes, TCP/IP, and similar things, which are usually separate services in the OS?
Cool, great question. So I will cover that in the very first time I start a container. So if I get here and I don't cover it, interrupt me and we'll loop back to that, okay?
All right, sounds good.
There's line 28 of the code. So let's get cracking on getting this started. I use environment variables pretty heavily when I do this demo because typing passwords can be challenging. And what you'll see here is I am highlighting the code at the top and it's executing on the bottom. And so we want to interface with Docker, right? I have Docker installed on my Mac, and in the notes for the session, I have how to install Docker on the various platforms. But in the end, it doesn't matter because you're going to get this type of interface where you have a command line tool called Docker. Now, when you're working with Docker, we say we want to give it a verb, in this case, Docker search. And well, what do I want to search for? I want to search for anything that's got the string MSSQL-server in it. And I want to go ahead and pipe that into sort, so it sorts the output. Now, what this is going to do is enumerate a list of the container images that have that string in their description. And so you can see here, I have a pretty big list of container images that are available on the Docker Hub. And so there we can see the official container image that is from Microsoft in their container registry, but it's been deprecated here because that's been moved over to mcr.microsoft.com. But it's just a quick way to show you how to search a container registry. If you want to work with a particular container registry, this is the syntax to do that. So here you can see I have the command Docker, and I'm going to pull the container from mcr.microsoft.com, which is Microsoft's container registry. MSSQL is the directory, server is the container image, and this here at the end is what's called a tag. And this is what uniquely identifies a particular container. So here you can see we have a 2017 container that's CU5 and of type Ubuntu. And so when I go ahead and run this code, it's going to pull that container image from mcr.microsoft.com down to my local OS. I did that before because downloading 1.3 gigs can get a little bit dicey on my internet connection, but Docker already knows that I have it downloaded, and it's like, hey, you know what? You're up to date. You can use that. Another common thing, we're going to use the CU15 image today, but a common way to pull images is to use this latest tag. And so here you can see the tag starts here, 2017-latest. What that means is the person or the people that maintain the container registry will have a latest tag that points to what is the most recent or the latest image that's available. In this case, it's going to be CU16. I'm having a little bit of trouble with CU16 today, so I'm going to pin our demos to CU15. And so that's what you'll see for the rest of this. If you want to ask your container registry what different tags are available, you can browse to that, or if you like me at the command line, you can do it like this. And I give a shout out to Andrew Prusky here for pulling together this line of code. We're going to do an invoke web request against the container registry, and here we're going to enumerate a list of all of the tags that are available inside of this container registry. And so as we go up this list, we can see 2019 latest, CTP 3.2 for 2019. And scroll back, we'll see a container image for each of the released versions of SQL Server. So here you can see for CU 2, 3, 4, all the way up to 16. And so that's going to be the release cycle for container images is based off CU and obviously the larger version. So now we saw me do a Docker pull a minute ago. Well, what images do I have on my local system? And we can use Docker images to do that. And so here you can see all of the various container images that are on my local system. And it's a lot to sift through because I do a lot of work with containers. But let's go ahead and use the command grep to kind of filter off things that have the word SQL in it. So here we can see I have 2017 latest from this particular container image. It's got to have an ID, when it was published, and its size. So 1.36 gig for 2017 latest, which is CU16. We also see some newer versions of 2019 down here at the bottom, and so on. If I want to look inside of a container image, let me start over that. My favorite command in Docker is this, inspect, because I like to look inside of things to understand how they work. And if ever I need a little bit more data about the thing that I'm working with Docker, I use inspect. And so here we see I'm going to use inspect because I'm going to look at a Docker image. So I say Docker image inspect. What image do I want to look at? That CU15 image that we're going to work with today. I'm going to pipe that into more so the output doesn't run off the screen real fast. Now here you see a kind of a JSON description of what the container is in terms of configuration. Basically, this is going to be the stuff that the developer put into the Docker file when it built the Docker image. Some of them are defaults, but gives you a good feel of how the thing was really built. And if we go through here, we can see something that pops out right away that as DBAs are probably all familiar with is 1433 TCP is exposed as an exposed port. Now, when we talk about container networking, if you remember that networking was one of the namespaces available in terms of isolating an executing process. When a container is up and running, a container can think it's running on 1433. I can have 10 containers running on an OS that are all running on 1433, but it's up to Docker to expose them to the underlying network on a separate port. I'm going to show you how to do that when we get into the demonstrations. We have some environment variables that are set. We can see the command or the entry point to our application is going to be the application SQL Server, right? So this is going to be where SQL Server on Linux lives inside of the container. We also have an image hash, which makes sure that this image is exactly what the person that created the image and published it, it still looks like. Because if you think about what you're doing is you're pulling this code arbitrarily off the internet and running it on your local system. Well, we certainly want to make sure that there's a protection mechanism in there for that, and that's what the image hash does. So it's going to break out of there and get into Docker run. So the question was earlier, how do I affect configuration into my SQL Server? How do I take this thing, right, this runtime or this read-only image that's being published by Microsoft, and how do I get configuration in there, right? This is how you do that, is with environment variables. And so this command here, Docker run, is how we start a container. So this is the very first time we're going to start this container. and we're going to affect some configuration on it. In this case, very, very basic. We're going to accept the EULA, and we're going to set an NSA password. And so as SQL Server starts up, it knows, the process knows to go look at the environment variables that are available to it. And of course, we have to accept the EULA, and the very, very first time is we have to set an SA password. Now, there are lots of other environment variables available to us to configure SQL Server running inside of a container. Probably somewhere in a range of 20 to 30 different configuration options. There's also another technique that we can use with MS SQL Conf, which is the tool that you use to configure SQL Server on Linux. And we can leverage, or we can use a container, start up, and we can execute MS SQL Conf commands on the instantiation of the container to affect more configuration. So MS SQL Conf is kind of the, I don't want to say replacement, but the comparable tool to Configuration Manager in SQL Server on Linux. So the combination of environment variables, MS SQL Conf gets you the surface area to configure your container. So with that, so Docker run, 2 environment variables. We're going to give our container a name. I talked about the concept of inside the container and outside the container. This is the exposed port inside of the container, the one that we saw in the JSON file. And this is the port that we're going to expose our container on the local OS. Now we're going to detach the container from the running terminal, basically meaning start the process up but put it in the background. And then this is the container that we're going to run, the one that we have been working with so far. So let's go ahead and run this code. And I'm still in the PowerShell prompt. Let's get an exit out of that, clear the screen, and rerun this code not in PowerShell. We certainly could run it in PowerShell, but I'm using this line continuation technique, which makes PowerShell sad. So when you see this, I have a container up and running. I also have SQL Server up and running. By the time I get to these commands down here, SQL Server, in fact, I bet you if I run it now, SQL Server is already up and running. But before we get to that, and that just took a few seconds, which is, I think, pretty remarkable. Let's talk about some other commands that we use to work with Docker if something went wrong when I tried to run Docker run. Docker help is, again, the help interface. Docker help what? I want help on the run command. I can pipe that into more, and I can get all of the various attributes that go along with Docker run. Being one of the more complicated commands, you'll spend some time in here fishing around. So you see things in here like block IO wait, CPU period, CPU quota. Again, this is how you can affect the runtime configuration of your container. If something went wrong starting your container, Docker logs, the container name, pipe it into more, and you'll get anything that your process wrote to standard out when it was running in your container. So if you try to start up SQL Server and you Docker run and it doesn't start, and you're trying to figure out why you can't connect to the SQL instance, that goes straight here, right? Docker logs, the name of the container, and chances are it's going to tell you, this output here is going to tell you what's wrong. Now, if you're looking at this output, it looks familiar to you, it is. This is the SQL Server error log. And so here we can see the standard SQL Server error log for starting up a SQL Server on Linux instance. As we go through all of these things, they should be very familiar to you as a DBA. I can use Docker PS to get a list of running containers. So this means my application is up and running. And so from left to right, we see the container ID, which is a unique identifier for this particular container, the image that it's running, the command that it used to start up, when it was created, its current status, and its networking configuration. It always runs off on the end there. So let me rerun that. And so here you can see it's listing on all IPs on this machine on 1433 and forwarding that traffic into the container on 1433. And so with that, I kind of let the cat out of the bag, you doing this line of code earlier, but we have SQL Server up and running. This here, the host name from AT server name is the actual container ID, so those match. And we can see the version of SQL Server that we're running is going to be CU15. Now, special shout out to work. Let's look at how we would connect to this container with Azure Data Studio. And so I have Azure Data Studio somewhere up and running. I had it up and running. Let's go ahead and launch that, maximize the window. If I have a connection here, let's go ahead and look at the connection attributes. If I do a right click manage, and we can see that I'm connected to this particular instance. I'm pointing to localhost on 1433, but that could be any IP where the container is running. And so we can see that the computer name ends in 468, which was the container ID here, 468. So we're pointing at that container instance from ADS, and we can go about our business managing this instance using Azure Data Studio or SSMS, right? Whatever tool it is, you need to get it done. But Azure Data Studio kind of being the future and kind of the hub for the data platform as things progress in the data platform space. Yeah, I want to make sure that I launched that manage screen too, which it did. All right, let's start a second container and get a second instance of SQL Server up and running. It's a Docker run, SQL 2. This time I'm using the short name parameters, where a second ago I used the long parameters, see --env, name, publish. You can shorten it up to -e, -p, -d, and get our application up and going this way. So Docker run, name, configuration. I have to make a slight change to the ports because 1433 is already taken by our other container. So I have to set it to 1434, but still pointing to the internal port of 1433 inside of the container. I do a Docker run, and now I have a second instance of SQL Server up and running. At the bottom here, we can see that with the container ID popping out. Let's go ahead and run this. We see Docker PS to get a listing. SQL 2 is up, SQL 1 is up, and they've been up for a couple of minutes here and a couple of seconds there, and on a different IP and port. And that's the multi-instance solution for SQL Server on Linux, in fact, because there is no concept of a named instance in SQL Server on Linux. So leveraging containers is how you can get that same feel of having multiple instances up and running. Go ahead and check the server name. We can see here it ends in 5E3, and that's going to be the name of that other container. So let's go ahead and start this process off. We're going to copy a wide world importers into, so we say Docker CP. I'm going to copy a backup in my current working directory into the container name SQL1 at this location, which is the default data location for databases in SQL Server on Linux. Now, what we're doing now is on SQL 2, which is on 1434. We're going to restore wide world importers. So if I look inside the SQL script here, it's just a simple restore database with move to get everything in the right locations. And there we can see that finished. And so what I want to show you now is what happens when we go inside of the container. So we have SQL 1 up, we have SQL 2 up, and I just restored a backup. Let's go ahead and use this command, docker exec, to give me an integrated terminal into SQL 2 and run this process bin bash, which is going to give me a command line shell. If I do a process listing or ps-aux, I'm going to get a list of all the processes running inside the container, right? Because docker exec bin bash puts that shell in the container. So it's as if I'm inside the container looking around. And I asked my Linux operating system, hey, how many processes do you have up and running? I have 4, right? But if you think about it, there's usually a lot more processes running inside of an OS, but this is where that isolation comes in. And so you can see I have 2 SQL Server on Linux processes, the bash process that I'm using to run a shell to interact with the container, and then ps-aux, which is the process that we're using to get a directory listing. And so that process isolation, you can see it very visually here, is that this is all that it thinks is running inside of the container. If I go and get a directory listing on where our data is, you can see all of this stuff just popped up a few seconds ago inside of our container when we've restored the database and started the container up here. So let's go ahead and exit out of our container and get back onto the command line. So now if I stop this container SQL 2, that's going to send a sig kill into the process and gracefully shut down SQL Server. So sometimes that might take a second because it's got to do all the goodness it has to do to shut down the database engine gracefully. If I do a Docker PS, now I see only 1 container up and running, SQL 1. If I do a ps-a, I see SQL 1 and SQL 2. But SQL 2 is stopped, right? Its status is exit at 0, which means it gracefully shut down. Exit status of 0 is a good thing. Everything's shut down, happy. I can start that container back up by just saying, hey, Docker start SQL 2. I don't need all of the stuff that I had to use initially to start that container back up because it's part of that container's configuration that we see in this list here. That data is still going to be there as well because it's part of the writable layer inside of the container for the database that we restored in SQL 2. So let's go ahead and do a Docker PS. We can see both are up and running. That's cool. Let's move forward and shut them both down. Right here you can see Docker stop. And I'm using a technique called bash expansion, which will run basically a Docker stop 1, Docker stop 2, one right after the other. If I do a PS minus A, we'll see that both exit it gracefully. Now, if I remove those containers, RM1 or Docker RM SQL 1, Docker RM SQL 2, again using bash expansion, now the data that was part of the writable layer of SQL 2 is gone, right? Because we didn't store it outside of the container like we talked about in the presentation. So let's go ahead and do that now. And I do want to point out that if we do Docker image ls, our CU15 container is still here, right? So the instantiator, or excuse me, our CU15 image is still here. Our containers, SQL1 and SQL2, are the ones that went away. Now, from a data persistency standpoint, let's go ahead and use this code here. Very similar to what we had, Docker run, give it a name, SQL1, give it a configuration, give it a port, and we're going to add this -v parameter now, and we're going to use a named Docker data volume, SQL data 1, and we're going to mount it inside of our container at var opt MSSQL, which is the default location for the instance inside the container. And we're going to run the CU15 container. What this is going to do is take var opt MSSQL and map it back to a physical location on my underlying OS. And so when I conduct IO, well, the container thinks it's writing var opt MSSQL, but in fact, it's actually getting written out externally outside of my container into the base OS. And so let's go ahead and copy a backup in again. So we're going to copy in wide world importers to SQL1 at that location. Go ahead and restore that there and get that up and running. It's always kind of funny when I do this demo. Every once in a while, I'll fat finger something, and this restore takes a minute or two, and then I have to wait, and then I'll get the error that says you could not connect to your SQL instance, network timeout, and then I have to troubleshoot that live, and it gets to be very exciting. But in this case, we did okay. We've restored the database. So let's ask SQL Server for a list of databases that are available, right? It's going to pull from sys.databases, master tempdb model, MSDB, wide world importers, which we just put there. Let's go ahead and get a list of the files inside of accompanied with the database. So here we see wide world importers, and all of those live in var opt MSSQL, which we learned is actually pointing to the Docker data volume. And so that as SQL Server writes these locations, well, it thinks it's there, but in fact, it's actually somewhere else on the base OS. So now if I do a Docker stop and shut down the container, and I do a Docker RM and delete the container, where when I deleted the container before, the writable layer went away. Well, in this case, the writable layer still goes away, but the stuff that's important to me lives in var opt MSSQL. So I can instantiate another container, mount that same data volume, and I can go query the list of databases, and I see that my data is still there, right? So think about what we just did. Started up a container, mounted a data volume, restored the database, deleted the container, started up a new container pointing at that existing data volume, and got exactly back to where we were from a configuration standpoint for our databases. Now, other user databases obviously would be available. Configuration would be decoupled. We make sure to assert that with environment variables and MSSQL conf. And so that kind of brings it all together such that we can just throw away the container and bring a new one down when we're ready. If I wanted to get so cavalier as to do an upgrade, so I can Docker image ls pipe grep SQL. I could grab one of these newer container images, say 2019 latest, put it right here. I could stop SQL1. So I just issued a Docker stop SQL1. I changed the container tag from 17cu15. I run, I got to upgrade, or I got to stop the container, or excuse me, I got to delete the container. So I stop the container, delete the container, upgrade the image. Now run that. And if I ask SQL Server to give me a list of databases, it's telling me right now it's running the upgrade scripts basically to move to 2019. So what we just did there was I stopped the 2017 container, deleted it, updated the image name that we want to launch to 2019, started that container up again with Docker run. And if I go ahead and go through, hopefully we'll see it pretty quickly. And there we go. Boom, we have a 2019 instance of SQL Server up and running. How fast have you ever seen an upgrade of SQL Server go that fast? I haven't. Well, I have because I've done this demo before, but hopefully you haven't. Now you see Docker volume ls, that's where our data actually lives. Where does that actually live in our underlying OS? Remember I told you my favorite command is inspect, Docker volume inspect, SQL data 1. And that's actually where it lives on my base OS, is in this real location here. So let's go ahead and stop our container and remove our container. And if I delete this, Docker volume RM SQL data 1, that's when my data actually goes away for real in this configuration. So let's jump back into the presentation. How are we doing on questions there, Warwick? Anything interesting or anything that you want to bring up?
Okay, so we do have a couple of questions. First one, is there a performance difference between Windows and Linux containers for SQL Server?
Specifically Windows containers versus SQL Server on Linux containers?
Yes.
I don't have like real perf numbers on that, but let's just say my observations I've seen better performance out of some Linux scenarios, but I think that's going to be dependent upon the workload and the problems you're trying to solve. So I'm going to punt on that question.
Okay. So from a memory configuration, does a container use all of the entire physical server memory that the container is running on, or not leaving enough for any other containers?
So the memory pressure has been a unique topic for me that I've worked with, and I've blogged about it a lot. And so there are scenarios where I've seen SQL Server still page in external memory pressure situations, which is what you would see between two separate SQL instances competing for the resources of the underlying OS. So what you can do in containers is in Docker run, you can put boundaries around how much you want for each container. I can say this container can only use 6 gigs. That container can only use 10 gigs. And then also you have the ability to do min and max memory at the instance level. Now here's where things get crazy. We haven't talked about container orchestration yet, but we will in just in a matter of minutes. Container orchestrators, specifically Kubernetes, have no swap, right? So if you do have an external memory pressure situation, it'll kill the container and redeploy it because it's trying to protect the underlying host to prevent swapping from dragging down the whole host. So that goes into having to very nicely be able to make sure that your workload's distributed across the nodes in your Kubernetes cluster, which I haven't discussed yet. And so that balance is one of the things that values that Kubernetes provides is where do you run your workload? If somebody gets naughty, kill that workload and move it somewhere else, right?
Okay. So one other question before we just continue. So is it possible to have SSIS in a Docker container? And is it possible, if so, is it possible to publish an SSIS package into a container?
SQL Server container SSIS. Yes, I'm not. I want to see. Yeah, I don't know about SSIS off the top of my head. I know it's available for SQL Server and Linux. I know it's very basic execution, but I don't know specifically about containers. I thought I'd be able to get the answer very quickly, but that's I don't know the exact answer to that. I know it exists for SQL Server and Linux, but I don't know if it's available for containers yet. But I know other features are available for containers. I guess in theory, you'd be able to just build. So this is kind of a little deeper of a topic, but you can build your own custom container image. And I've done it for Polybase and I've done it for SQL Agent. So I imagine you would just be able to do it for SSIS as well. So any of the features for SQL Server on Linux are installed as extra packages, right? So if you go and you install a SQL Server on Linux with apt-get MSSQL Server, apt-get MSSQL Server -SQL Agent, and then you take that and you package it up in container and consume that. And so you go through this process here, right? But you're doing it now as an individual. You're writing a Docker file that says install SQL Server on Linux, install SSIS, build me a container and run it. So yeah, actually you can do that.
Okay, so just had a comment saying that SSIS is not available on Linux.
That's not entirely true. Yeah, integration services on Linux. So it's not as full featured as Windows, but it exists. So
Okay.
you still there?
Yes.
Oh, okay. All right. Do you want to get cooking then?
Yes, we can.
Okay, cool. So we did a lot in the demos. We pulled an image, we ran a container, we accessed the container both with SQL CMD and ADS. And we also hopped in the container with bin bash and looked around. It looked at some persistent data with the container and how we could leverage Docker data volumes to help us with that. And we also upgraded SQL Server, threw that in there for some fun. Now let's talk about container orchestrators. I used the term Kubernetes a second ago and talked about work and how that would all work. Well, and we kind of discussed this scenario, right? Workload placement. That's what Kubernetes provides. Kind of the number one feature that Kubernetes provides is workload placement. So think about this. Where do I start my container in my data center? If I have a collection of computers, who makes the decision on where to run that container in that cluster of computers? And that's what a container orchestrator does. Where do I run an individual container or collection of containers, and making sure that the underlying OS has the resources to run the application that I want it to run, right? If I need a IP address, if I need a port exposed, if I need a particular type of storage mounted, that's the job of a container orchestrator. Now, it also has the job of managing state. What that means is I can tell a container orchestrator like Kubernetes, hey, I want you to run one SQL Server and just make sure you keep that container up all the time. And also mount this storage over here all the time. And with that, I get basic high availability. And we'll look at the internals of that in a second. Workload orchestrators also provide load balancing. They provide a networking abstraction, so I don't have to get in the business of remembering all the IPs of all the individual pods or containers that are running in my apps. I get some nice DNS abstraction and also persistent IPs if I need it, persistent storage, which we discussed, and I get this all with a declarative model. What that means is I don't tell a container orchestrator where to start the container, what port to run it on, where do I need, what particular server do I need to run it on. I just tell the container orchestrator, hey, run this container image, give it a public IP address or not, and expose that to me. And oh yeah, and maybe mount 500 gigabytes of this type of storage. And then expose that to me as a networking abstraction or a DNS name, and I can just consume that application as I want, right? And I get that, and I write that in code. I take that code and I store it in a repository, and I have, well, the code that instantiate my application declaratively, and my application is up and running in my cluster, and I didn't have to go bolt all those pieces together imperatively at the command line. And so those were kind of the general concepts of container orchestration. Let's look at specifically container orchestrators. There's Docker Swarm, there's Kubernetes, and Red Hat OpenShift. Those are kind of the big fish in the container orchestrator world. Now, between Kubernetes and Docker Swarm, Kubernetes won the battle of the orchestrators, right? It's kind of the big one that's out there, but that's an open source project. And if you're the kind of organization that needs to have an off-the-shelf product from a vendor, Red Hat OpenShift is Kubernetes, but branded and sold by Red Hat. Now, I think that's the number one reason why IBM bought Red Hat is because of that right there. And that can tell you kind of the impact that I think, or even the people at IBM think, that Kubernetes is going to have on the future state of infrastructure. Now, from a managed service perspective, there's AKS, there's GKE, and EKS. I've used all of these, and I kind of have a warm and fuzzy feeling with AKS, and I use that actually primarily as the cluster that I use when I'm doing testing and development in my own scenarios. They use an AKS cluster. Now, you could get Kubernetes very quickly if you're using Docker, and this is a very analogous scenario on a PC. If you go to your preferences menu where you might used to be configuring all the other options, there's a Kubernetes button right here. You check this checkbox, and a few minutes later, you'll have a Kubernetes cluster on your local desktop for development purposes. So let's keep moving forward and talk about kind of the services that container orchestrators provide. I know we're kind of in the red zone here. We're about 4 minutes away from being done. So services, you heard me talk about abstraction earlier. And focus on just making sure that the service is available, and that's where orchestrators come in. So imagine I have a physical infrastructure that looks like this, a couple physical machines running a host OS, and I have some containers up and running, and my container orchestrator can start those containers for me. Yeah, it can do that, but it also can do this. It can abstract away both a name and an IP for access to the applications on those containers. In fact, what it'll do is it'll take those containers, register their IPs behind a load balancer, and if I tell it to, it'll distribute the workload intelligently between all the different containers that are part of that service, in this case, app one. If something goes bump in the night and my container dies or that entire host dies, the container orchestrator is smart enough to deregister that failed container from the service and continue distributing workload to the live containers. And if I told it to, a container orchestrator is smart enough to do this, instantiate a container. Because of the ephemerality concepts of a container, that application will always go back to a known starting point. Its configuration will be asserted externally. And if there's any state, well, I can just mount that volume inside the container. And what the container orchestrator will do is re-register that application and start distributing workload to it again. And that all happens without human interaction, right? We've told it to do this, but this all happens for us out of the box. Well, not out of the box, but if we configure it inside of our cluster. Now, let's kind of zip this or shift over to how we can apply that technique to SQL Server, right? Because SQL Server can't really stand arbitrarily behind a load balancer across multiple containers, right? So let's see how we do this in SQL Server terms. Now, we have a physical machine with the host OS on it running a container runtime, likely Docker, and leveraging a container orchestrator for workload distribution. Now, the container orchestrator, we have the substrate of a persistent volume, right? This could be a SAN, this could be Azure File or Azure Disk, a GKE disk or EBS in AWS. But there's this ability to put some sort of persistent volume underneath these physical machines, right? And with that, in our container orchestrator, we can define, in this case, is a Kubernetes specific concept called a replica set, right? What the replica set will do is make sure that I have one SQL Server container up at all times. Now, a replica set can be used to start n number of containers, but since it's SQL and I only want to have one up and running at all times, I'm going to define one in the replica set. Now, it's the job of the cluster to make sure that that one container is always available. I'm also going to tell it to mount an external container inside of this persistent volume and use that technique similar to Docker data volume to expose that inside of the running container. And so what that means is I can then expose that as a service. Right now I have a load balanced service of one, which is still, it sounds kind of weird, but watch this. If something goes wrong with this container and it dies, well, it's going to deregister that from the load balancer. It's going to realize that the container died. And since I told the replica set I want to have one running at all times, it's going to deploy a new container. It's going to mount that volume and register the service. And I basically get a similar functionality to a failover cluster outside of my platform, right? Inside of my container orchestrator, most likely Kubernetes. And that is the value that we can leverage inside as data platform professionals to provide high availability services for our data platform or for our SQL instances. Now, what's cool about this is I use no SQL Server specific technologies. Now, the rest of my application infrastructure can leverage these same technologies and techniques. And so what's next? Is this production ready, right? Yeah, I think we're there. When I started working with containers initially, I kind of danced around this a little bit and it's like, maybe not. But in the end, the thing that needs to become production ready is you, right? Do you have the skills to support these new technologies and techniques effectively without impacting the business or hopefully positively impacting the business? Are you production ready? The next thing is just to go out there and kind of evangelize about this session and other things. I think this is game-changing stuff, right? I think that containers and Kubernetes in the next 5 years is going to be how we'll be deploying SQL Server in our data centers. Now, from a review standpoint, we covered tons and tons of material today. We covered what is a container, how it fits in our data center, why we would rerun SQL Server in a container. We looked at kind of the big players in the container universe, lots and lots of demos. I'll make the code available in a matter of minutes once we're done. The need for container orchestration and also how we can get high availability services out of our containers. I have lots and lots of information available to you. Go ahead and if you have any questions, shoot me an email. Please follow me on Twitter. I blog, like I said, relatively frequently. And if you've never used SQL Server on Linux or Linux before, check out my Pluralsight courses here. And then I kind of go into some deeper dive stuff about Kubernetes, but those are kind of the core educational constructs that I have available to you. If you want free access to this content, I'm not trying to sell you anything here. If you want free access to the content, shoot me an email and I'll give you a 30-day trial code so that you can spend as much time as you want with getting into this a little bit more than the hour that we had together tonight. So let's go ahead and kick it back to you, Warwick. Any questions or comments?
Okay, so as a summary, spinning up a container can be used for anything, but given that we're here talking about SQL Server runs as a service inside of the container. Yeah?
Mm-hmm. Yeah.
And you've got, just like in a VM, you've got the ability to configure certain resources, CPU, memory, to the container, just like you can with a VM. And if you're wanting that to be persistent, you can provision a persisted disk out on the local system. And for all intensive purposes, it looks like a virtual server.
Yeah. Yeah. You know, container professionals generally don't want to make the analogies back to virtual machines too much, but in that sense, yeah, I mean, we're multiplexing the OS, right, rather than hardware.
Yes. So it's just trying to make sure that, because majority of people on this call would potentially understand a virtual machine. So I'm just summarizing from that side of things. Now, cool. How do containers work if the underlying shared OS kernel needs to be patched or rebooted?
So that was dicey in the beginnings of the container journey, I guess you could say. But now in this case, as long as the underlying OS still can respect the system calls that the container needs to run, things should work fine. I think that in my experience, I haven't had to bump into that too much because I've been working with containers for about 2 years, but I know before that there were some dicey scenarios that had existed. Ideally in production environment, you can be leveraging something like Kubernetes, where you can move your workload to a patch and updated kernel and go from there, right? Because in the end, that the process that's executing inside of the container doesn't care about kernel version 2.6.2.5.2.8 or whatever that is from a Linux standpoint. It cares is the read system call there? Is the write system call there, right? Are those things available to me as a service?
Okay. Now, on one of the previous slides mentioned about, is this production ready? Are there limited, or is it limited to the size that you can create a container?
So the size from a CPU disk RAM standpoint is going to be OS limits or edition limits. There's no, I don't know of any boundary specific to containers for that.
Okay. Is there a limit, or is it purely bound on the resources available? But is there a limit on the number of containers that you can run on a typical Ubuntu server?
You're going to run out of other resources before you run out of anything that would actually block the container specifically from running. Like you're running out of CPU disk RAM. Things that you would run out of after that are going to be, or you'd bump into things like inode limits or ulimit or other ulimit limited resources inside of the OS. Like I would see, because in the end they're just processes instantiating. When I so from some of the larger scale web farm deployments that I would run into, you'll see, things like Apache and Nginx would spin up additional processes and threads. You start running into wonkiness with tens of thousands of threads and processes running, but that's not OS boundaries. Usually it's some sort of security boundary that you bump into, whether it's be ulimit or SC Linux or things like that, preventing you from going past that. But you'd run out of OS resources before any conceptual container issues become an issue.
Okay. Now, in the demo, you showed a Docker search with a sort. But when we do a search, a sort, there are no tags for SQL Server 2017 or 2019. Should we see those tags? And if so, why would they not be being shown?
So searching and sorting in Docker registries has always been kind of a thorn in our sides. And so this specifically went against the Docker Hub. And I don't know the syntax exactly how to specify searching against the individual container registry. So this is the technique that I've been using to do that, is with this PowerShell technique where I pull the tags here for the container image that I want to work with. So if we go do this, and then I run this block of code to get a list of tags, that's when I get all of that stuff. Now, part of it is this one is deprecated and Microsoft's not publishing new stuff there. I thought they were syndicated back, but it doesn't seem to be the case, meaning they're published to theirs and it'll get syndicated back over to Docker Hub, but it doesn't seem to be the case.
Okay. Now, last question. And so how is SQL Server licensed in containers? Is it linked to the host running my containers?
The official word is the same as VMs. So all of those concepts would apply. So per server, or if you license the whole underlying OS with the enterprise virtualization benefit. But I'm going to throw the caveat in there. I am not a licensing professional. Contact your reseller.
Fair enough. All right. Well, if there's, excuse me, if there's no more questions, I'd like to say a big thank you to Anthony for this month's session. I'd like to say a big thank you to all of the attendees for coming along to this session. Make sure that you register if you haven't already registered for next month's session, and I look forward to seeing you all at the same time. Thanks, everybody.
Thanks for having me. Thanks for coming, guys.